Welcome to the Gut Pharmacist podcast. I have an elite speaker today who knows all about the gut microbiome and everything to do with the gut brain connection. Kiran is here with us, and I've learned so much from him since starting my gut health journey just a few years ago. But thanks for being on my show.
It is a pleasure. Thank you so much for having me.
Of course. Yeah, it's an honor to have you. So tell us quickly why you got into the field that you're in, why microbiology and gut health.
Yeah, absolutely. So I got into microbiology. Well, I think number one because I was born a nerd, so it was going to be something in science. My parents are both from the scientific field, right? So my mom's a medical doctor, and my dad was a microelectronics engineer. So I had kind of both schools of the hard, mathematical sciences as well as the softer biological sciences as well. I was always exposed to both. My battle when I was thinking about what to study in the world of science, it was either going to be physics and quantum mechanics or microbiology, and they both
Wow.
have lots of similarities, right? And they both appeal to me for the same reasons, and it was this universe of unseen, kind of in many cases unknown things that impact every aspect of your life, right? So atoms and subatomic particles and quantum mechanics impact your life in ways that you have no idea, no concept of from day to day. Same thing with the microbial world. The microbial world impacts your life, in a very significant way. Mostly goes unnoticed by most people, and so in trying to decide which one I wanted to do, actually, Hollywood played a role in that. So
Wow.
my first right, so it comes back down to movies, and so my first week at school, as I was trying to decide, where I wanted to major, what I wanted to focus in on, there was that movie Outbreak that came out. If you remember, you might
Oh,
be too young,
yes. Yeah.
with Morgan Freeman and Dustin Hoffman, right? It was about
Yes.
a viral outbreak in a town, and these were NIH scientists and virologists kind of chasing this infection, trying to figure out a cure, and that seems super exciting to me. And so that's when I decided on microbiology. Now, when I got into the world of microbiology and I started doing research work, like a lot of microbiologists, you focus on pathogens, and I was working on pathogens. I had two big research projects, one on infectious E. coli, another one on HIV. And so, but then you realize after a period of time, at least I did, that the vast majority of microbes are really either beneficial or not harmful, And in fact, there was I got interviewed for an article in U.S. News and World Report a number of years ago, and they wanted to talk about like antibiotic resistance and so on, and microbes in general. And I did a calculation for one of their questions, and basically it turns out that about 0.1% of all microbes ever discovered are actually harmful in some way, right? Which means
Okay.
that
Wow.
99 point, right, which is a tiny fraction. It's quite surprising. It was surprising to me as I dug through the literature to try to figure this out, which means that 99.9% of all microbes that we've discovered so far are either benign or beneficial in some way. And that 0.1% gets so much attention, right? And
It
and we
does.
we create, right? Create all this technology and invention to try to control that 0.1%, whether it's antibiotics, antimicrobials, cleaners, this, that, and the other. When at the end of the day, the best way always to control the 0.1% is to let the 99.9% flourish. And so that gave me a strong interest in the other 99.9%. And that naturally became a study of the microbiome, because our biome is generally made up of beneficial, commensal, or benign microbes that control in large part the difficult microbes, the pathogenic ones. And then, of course, as you dig into the microbiome, you come to find out that they also control virtually everything. So that was, in short form, my journey into this field.
Thank you for sharing that. And it all makes sense how you got to this point. And I think that was a great intro into the first question. So I just want to keep it very simple for viewers of all education ranges. So, starting
Mhm.
simple, what is the microbiome or microbiota and where is it in the body?
Yeah. So the microbiome, and there's a difference. You mentioned two words there, so I think we should define both words for them. So the microbiome is defined as the totality of microbes and all of their genetic elements, right? So that's viruses, bacteria, protozoa, all kinds of different organisms, and then all of their genetic elements itself. All of that is called the microbiome. Now, the microbiome, in the context of the host, which is us, exists almost everywhere in the host. The largest densities in the digestive tract, of course, all the way starting from your mouth to your bottom. And incidentally, it's interesting when you think about the distribution of bacteria and other microbes in the body. The digestive tract is a massive surface area, right? And maybe people don't know this, but if you fold out all of your digestive tract, it has the surface area of about a professional tennis court, which is huge, right? It's a big, big surface area. Compare that to the surface area of your mouth, which is actually not that big. And yet the mouth harbors somewhere around 22-23% of all the microbes that live in your body. The gut harbors around 29 to 30%. Right. So it's more, but not that much more considering the surface area. So the mouth and the gut contain the vast majority of microbes, but everywhere else you have microbes, your skin, your cerebral spinal fluid, your eyeballs, your brain, everything else, with the exception of your mucosa, of part of your mucosal lining in your digestive tract. That's this really unique sterile area of your body that doesn't allow in a healthy system for harboring of microbes. And maybe we would talk about why it's structured that way. But that's the microbiome. So it's all the microbes and their genetic elements. The microbiota is the microbial population in a specific area of the body. So you'd say the gut microbiota, the skin microbiota, the hair microbiota. Then you're referring to the microbial population, not necessarily considering the genetic elements or the whole system, but you're speaking to a specific ecosystem site on the body.
Gotcha. Okay, so the microbiome is the whole, and the microbiota is individual parts of that whole, right?
That's
Gotcha.
exactly right. So the
Okay.
microbiome is made up of thousands of microbiotas all over the body.
Gotcha. Okay. And a lot of people don't realize that we need to keep our healthy skin, microbiota, healthy hair, scalp. It exists everywhere pretty
Mhm.
much. And a lot of people just forget that point. So, what are some important functions in the body, and probably all, but what are some major ones that require a healthy microbiome?
Yeah. So, the functionality of your different organ systems, and we're talking about every component of your body, right? Whether it's your gut and all the different sections of your gut, or your skin, as you mentioned, or your brain, and so on. The function of the organ is made up of really two factors. Number one is the structure of the organ, and number two is the ecosystem of the organ. If any one of those two things are off, the organ doesn't function like normal. Just take the skin. Let's take the skin as an example, right? We all know the skin is made up of very specific structure. The very top layer of the skin is called the epidermis. It has all these dead layers of dead skin cell. Below that is a dermis. And then you start going deeper and deeper into the skin. There's many different layers, many different types of capillary structures to feed blood to the skin. Then there's a mucosal layer under the skin, and so on. Now, that's the physiological structure of the skin. Now, the microbiological structure of the skin requires that the skin is inhabited predominantly by certain organisms like Staphylococcus epidermidis, and there's some amount of Staph aureus. There's a few other microbes there. Now, if the microbes are imbalanced on the skin won't function the way it should. The skin acts as a barrier system to the outside environment. It should be somewhat resilient, right? You should be able to encounter things, like rub it up against things, encounter natural compounds, eat things, and it acts as a barrier for your body. Some people's skin gets disrupted. They get things like dermatitis, they get eczema, they get psoriasis, they get acne, so they get inflammation on the skin, they get other types of dysfunction on the skin. Most of that is driven through the ecological system of the skin being off, having too much Staph aureus versus Staph epidermidis. Now your skin, which is an organ, functions completely differently. Another great example of that is your small intestines. Your small intestine has a particular physiological structure in terms of size, the length of it, the different sections of it, the duodenum, the jejunum, the ileum, and so on. It's got a particular type of lining in it, microvilli, in order to increase the surface area. And then you release bile into the small intestine. You get some hydrochloric acid. You release digestive enzymes. So those are all the physiological components of the small intestine that provide it function. However, if the microbial system in the small intestine is off, it completely screws up how that organ system works, right? So, for example, if you have something called SIBO, small intestinal bacterial overgrowth, where you have the wrong type of bacteria in that space and too much of the wrong type of bacteria, the small intestine is no longer functioning like a small intestine should. It's no longer breaking down foods and assimilating nutrients the way it should. It's no longer moving food down towards the large intestine the way it should, right? It's no longer creating a large spectrum of absorption to be able to bring in nutrients. It's now inflamed, it's fermenting, it's getting bloating, it's producing gas, it's doing all these things that it's not supposed to do. Even though the physiological component is there, it's because the microbiological component is off, right? If the microbiology is fine, but you're missing something like a gallbladder, then the small intestine doesn't function properly because you're not secreting bile into it, right? So you have to have both of those in order for these organs to function the way they're supposed to. And again, it doesn't matter if it's your brain, if it's your gut, if it's your skin. All of these have a microbiology component and a physiological component.
Okay, so even the brain has a microbiota, is what you're saying. Now, that's crazy news to a lot of people, I bet.
Yeah.
So speaking of brain, there is a gut-brain connection, and we hear of leaky gut, leaky brain. So what actually happens with that intestinal permeability and then eventually LPS inflammation?
Yeah. And so the brain, and one of the things I always want to emphasize is that we talk about the gut brain connection. It's actually more than a connection, because I actually think of the gut and the brain as the same exact organ. It's just two parts of the same organ, right? They are intimately connected. They're formed at the same time in the embryo. They're formed from the same tissue. The tissue structures of the gut lining and the brain lining are almost exactly the same. It's bi-directional communication that's autonomous, meaning the microbes can talk to the brain as much as they want without our controls in place, and the brain can talk to the microbes equally with equal amount of frequency. And so they're two parts of the same system, and the brain, in fact, is dependent on the gut for lots of things, right? So it's dependent on the gut, for example, for serotonin and dopamine, which a lot of it is produced in the gut. People often think about those as brain-only hormones and neurotransmitters. It also, all of the neurotransmitters that we know that work in the brain are also functioning and produced and work in the gut. We also know that the brain counts on certain things like BDNF, brain-derived neurotrophic factor, which is made in the gut for healing of the brain every single night when we go to sleep. So there's a lot of supportive mechanisms between the two. Now, you mentioned something very critical where we talk about the leakiness of the gut. That's a dysfunctional gut, right? So that's a small and or large intestine where the microbiota in that area has gone awry. And because of that, the gut is not working the way it's supposed to. Its barrier system is leaky, and it's allowing in lots of things that it shouldn't allow to get absorbed into circulation. One of the key things that gets absorbed during this period of leakiness are endotoxins that are produced in the microbiota, in the gut microbiota in particular. There are lots of bacteria in the gut microbiota that produce toxins, and they produce toxins in a healthy gut. And most of those toxins, when produced in a healthy gut, get excreted through defecation. But if you don't have a healthy gut and your gut is dysfunctional and leaky, those toxins are going to leak into the system and end up in circulation. One of those is called LPS, as we mentioned, and that toxin can make its way into the brain, and it has an affinity for different parts of the brain where it lodges itself, and it does things like it interferes with serotonin binding in the brain. It also interferes with dopamine binding. That means your body can make enough serotonin or enough dopamine, but your brain can't utilize it properly. That means you could feel depressed, you could feel anxious all the time. It becomes really hard to alter your mood from kind of a saddened, low mood, right? It also creates lots of inflammation in the brain, which means your amino acid metabolism is off. So your brain and your central nervous system is constantly inflamed. You'll feel things like, brain fog, slower cognition. Over time, it actually starts to create neurodegeneration, where you actually start to lose brain tissue, which eventually becomes conditions like Alzheimer's, Parkinson's, dementia, and so on, right? So the important message here, and I'm sure people aren't going to remember all the details I just said, but the important message here for people is two things. Number one, the gut and the brain are two parts of the same system. So you need a healthy gut in order to have a healthy brain. And then a healthy brain will in turn support a healthy gut even more, right? They go hand in hand. That's message number one. Message number two is that unhealthy gut is arguably the most toxic thing to the brain. So your gut is either the brain's best friend or absolutely the worst enemy, right? So then you have to start to ask yourself a question: where is your gut on that spectrum? Is your gut on its way to becoming your brain's worst enemy, or is your gut currently your brain's best friend? I can help you answer that question, right? If you experience any sort of anxiety, if you experience any sort of low mood, any low level of depression or high level of depression, if you get panicked for no good reason during things, if you're really stressed all the time, if you feel brain fog and memory recall issues, and you stumbling on names and short-term memory issues, if you don't sleep well at night, you can't fall asleep appropriately, you can't stay asleep, all of these are early signs that your gut is acting in a toxigenic way to your brain. So it starts to become really important for you to fix your gut at that point.
So the gut is the brain and the brain is the gut. I think that's a very important key factor to take away. Now, are there
Absolutely.
some important strains? I know you call them keystone strains. Now,
Mhm.
not all of them can be supplemented, I know. So, what are some of those special strains and how can we increase these, or can we supplement some of them?
Yeah, so some of the most important keystone strains are Faecalibacter prosnitzi, F. prosnitzi, as you would call them, Akkermansia muciniphila, Bifidobacterium longum. Let's just take those three, because those three account for a big chunk of health and wellness. Akkermansia and Faecalum bacteria, you cannot supplement. They're strict anaerobes. They don't survive really outside of the body. They're not at all designed to go through the gastric system. And they work very deep in the large intestine, meaning far down in the large intestine. So it's really hard when you swallow them to get them all the way down there without them basically getting obliterated by stomach acid, bile salts, everything else that's in the digestive tract. And so the best route to try to increase those is try to do it naturally in ways in which they're designed to increase their numbers. And that is based on what you feed your gut microbiome, right? Or what you don't feed your gut microbiome. So let's take Akkermansia, for example. Akkermansia does really well during periods of fasting. So if you have the capability of adding in some periods of fasting into your diet, into your routine, that's great for Akkermansia, right? The second thing is Akkermansia also does really well with polyphenols. So polyphenols are the pigmented fruits, vegetables, and so on. Akkermansia feeds all those polyphenols really well. So increasing your intake of polyphenols can really, really drive Akkermansia growth. And if you add in a little bit of intermittent or other type of fasting into that, that really helps Akkermansia, that functional keystone species. The second one, Faecalibacter prosnitzi, does really well with resistant starches and prebiotics. So if you're eating things like, cassava and, sweet potato and plantains and all of these things that contain high levels of resistant starches, or prebiotics where you're getting oligosaccharides from plant fiber, from fruit fibers and things like that, or you can take supplemental prebiotics. We use oligosaccharides a lot as prebiotics. Those feed Akkermansia specifically. Bifidobacterium longum also loves prebiotics, so it does well with prebiotics, but fortunately, you can supplement some Bifidobacterium longum. We work with a Bifidobacterium longum called the 1714 strain, which has been shown to reduce anxiety, reduce depressive feelings and low mood, reduce neuronal inflammation, change brainwave activity, help you fall asleep. So it's doing all of the reversing that a dysfunctional gut does in terms of damage to the brain. So, you can feed those. In the case of Bifidobacterium longum, you can supplement it. But in general, you should always try to do the feeding part. That's a key primary aspect of developing your gut, is you want to feed and eat for your microbiome. And then where you can supplement, it's always nice to be able to supplement as well.
Right. Always have the basic foundation of nutrition for anything, and then the supplements can come after. Great point.
Exactly. Yeah. I mean,
And
you're not going to supplement your way out of bad choices and supplement your way out of bad habits, right? Supplements are just that. They are there to enhance your health, your wellness, and so on. But you need the basics. You need the foundation. You need the good habits, the good choices, and your food, lifestyle, and so on.
I totally agree. In the beginning, you mentioned the oral microbiome. I think a lot of people
Mhm.
don't know much about it. They're using their mouthwash every day, really strong toothpaste. So, is
Yeah.
bad breath actually a microbiome imbalance? So, kind of talk about the oral microbiome and how it's connected to the colon microbiome.
Yeah. And bad breath, there's a couple different things, right? So when you wake up in the morning and you have morning breath, that's different than bad breath, right? So bad breath, like halitosis, for example, people who have this chronic bad breath, there's a very noxious smell that comes out of their mouths, right? That's actually, it's very off-putting when you smell that. It's different than morning breath. Now, think about morning breath for a moment, right? And I know this because of this social programming. Morning breath we think of as gross, like you see in movies all the time. These couples, they roll out of bed first thing in the morning, they start kissing, right? And you go, oh my God, they're kissing before they're brushing their teeth because of the
Right.
morning breath, right? And you go, that's so fake because nobody kisses, nobody makes out in the morning in bed
Exactly.
because of the morning breath. But for millennia, humans probably did, right? Brushing is not a ancient thing. We've been doing it not, relatively recently, and certainly brushing with things like toothpaste that are fragranced and all that is a very new thing. So morning breath is probably a natural part of our human existence. And then as you eat throughout the day, it actually reduces the morning breath over time, right? And in fact, what's really important to note in the morning is that a lot of the bacteria that grow overnight in your mouth, one of their functions when you wake up is to actually produce more nitric oxide for you. And so it's part of the waking up process, right? So you wake up and then you start moving around and you start salivating again, because again, you get dehydrated at night. A lot of people's mouths get dry at night. So when you wake up, especially if you drink some water or you start salivating again, that activates a lot of the bacteria in your mouth to start producing nitric oxide, which is a very important compound for, improving perfusion and blood flow and energy. Critical thing in the morning, especially getting blood to your brain and so on, right? So if you wake up first thing in the morning and you go and you use an alcoholic-based mouthwash and try to sterilize your mouth, you're actually cutting out that whole process. And so we don't necessarily need to sterilize our mouth. That's not a good technique. The mechanical brushing is actually good. The benefits from mechanical brushing are not the toothpaste. The benefits of mechanical brushing is the mechanical component of it reduces some of the plaque growth, right? And again, you don't want to eliminate plaque. You want to reduce it because plaque is like an important structural element for certain bacteria to grow in your mouth. So with the mouth, it's about controlling microbial growth and controlling which microbes grow. Because if you eat too many sugars and things, you start feeding the wrong types of microbes in the mouth. And then you start getting overgrowth of dysfunctional microbes in the mouth, which you then swallow every second of every day through swallowing saliva. So you're getting massive inoculations within your GI tract of dysfunctional bacteria from your mouth, right? You're swallowing literally gallons of spit every day. You're swallowing hundreds of billions of bacteria. Now, on top of that, if something is off, like your stomach acid is off because you have H. pylori, or been taking antacids, or you're taking, proton pump inhibitors, for example, then more of the mouth bacteria are going to survive through, get into your gut, into your small and large intestine, and create disruptive ecosystems in that area, right? at the same time, you don't also want to sterilize your mouth, because then you're missing a lot of good functional bacteria within the mouth itself. So my practice is this. I actually wake up in the morning. I don't brush my teeth immediately when I wake up in the morning. The first thing I do is actually I take a nitrite tablet. I use it to enhance the nitric oxide production that's happening in the mouth. And that makes me actually feel much more alert. If I have time in the morning, I'm doing exercise and things like that, even before I brush my teeth. And then I may even have a cup of coffee before I brush my teeth. And then at some point, I'll brush my teeth, in kind of the late morning. I've given my mouth a couple hours for the microbes to kind of settle in and do what they're supposed to do. And when I do brush my teeth, I never use alcohol or sterilizing mouthwashes. Right? It's if I use toothpaste, it's tiny amount of very natural toothpaste, or you can just use some small amount of baking soda, and it's the mechanical abrasion of the toothbrush itself that reduces some of the plaque growth and reduces some of the microbial growth in your mouth. So then that's it. That's my morning routine.
That is so interesting. Okay, so mouthwash can actually inhibit nitric oxide production in the morning. It was one of your good
It absolutely
points.
does. It knocks it out. Yeah. So the last thing you want to do is wake up in the morning and go, oh, morning breath, sterilize my mouth with mouthwash.
Right. And so the oral microbiome really determines how the end of the microbiome looks, is what you're saying too.
Exactly.
Mm-hmm.
Mhm. Right.
Very okay.
Yep.
And so when it comes, I think you kind of answered this in the beginning, but let's kind of talk about it again. So a lot of physicians, practitioners, they have this approach with infections or dysbiosis or even the oral microbiome. There's a huge kill off approach. So is killing
Yeah.
off really the best way for all of these imbalances?
It's not, and I do my best of trying to train practitioners on this with all the lecturing that I do, and here's why, because it goes back to the thing we talked about earlier, right? Where it's about 0.1% of microbes are actually harmful or pathogenic, and their ability to be pathogenic is really determined by what the terrain looks like around them. Right. And so that is the real crux. Every time we try to kill things in an egregious way, and of course there are conditions in which you need to kill things, right? If I had a massive infection, if I had MRSA or something on my leg, I'm going to take an antibiotic so I don't lose my leg or lose or
Right.
die. So there are times when you need to kill things, but for most of these gut issues, these chronic gut issues, if we're trying to kill things all the time, what we're doing is just disrupting the terrain even more, because you cannot specifically kill just the bad guys. If you're using things like antimicrobials, antibiotics, you're killing everything. And so you're disrupting the terrain, and that allows for the disrupted microorganism to actually come back faster. Right. And so and we do a lot of gut testing. So we've done 10,000 plus microbiome analysis on patients in the US, and with many different types of conditions, mostly primary gut conditions. Rarely do we find that pathogens are the big problem, right? It's not so much who's there, it's who's not there. And the missing microbes and the missing functionality tends to be what is driving the dysfunction in these individuals. Now, when I say who's not there, I can mean that their presence is so low that they're not functional. They're still there,
Right.
present, but their levels are so low that they don't have functionality, right? It's no different than being in a city where you have one police officer and you go, well, we have police, but they're not doing anything because there's only one, right?
Right.
And so but then if you bring in and you do something to proliferate that one population into a functional group, now you've got a regain of their functionality. And so a lot of it we see is about bringing back functional organisms, bringing back commensals, bringing back keystone species that we talked about earlier, bringing back diversity into the gut microbiome, right? And when you do that, when you reestablish those ecosystems, you balance them out, you create stability, and then you bring back functionality. Because remember, it all goes back to what I said before. Every system in your body is dictated by the structure and the microbial ecosystem of that organ, right? And in these cases, in your gut, especially, your ecosystem is off, You got to bring back that population, or you're never going to reestablish function.
Right. And so things like SIBO, Candida, fungal overgrowth, the oregano, berberine, neem, are you not a fan of those microbial herbs?
I'm not certainly not for long-term use.
Right.
Maybe a short-term bursts of them for a week or two. Certainly not the rifaximin over and over again. We keep using those in 10, 12-day cycles, right? And just think about how the failure rate of those and the recurrence of SIBO, right? We've been doing the same kind of antimicrobial antibiotic approach to SIBO for years now without really any progress, right? It just keeps coming back. And that's because with every round that we do, we're disrupting the ecosystem even more, and we're not actually addressing the root cause of the problem. And so yeah, I'm fully my mindset is all about how do you regenerate the ecosystem rather than go in there and bomb it with things, with the hope that you'll kill the right thing.
Right. You might kill that thing, but you're going to kill everything else around it, which is why you have all
Exactly.
that relapsing. Makes a lot of sense. And I kind of say the same thing as well. It always depends on the person too, as you know, and the
Mhm.
type of infection and whatnot. So that was a lot of great information. Is there one more thing that you wanted to add? Any highlight that you wanted to leave the audience with?
Yeah, absolutely. I think to me, one of the most exciting things about being in this field that I am is that you come to really start to understand how the human system works, because we're now finally unveiling the big component of it, which is the microbial component of it, right? That was a bit of a mystery even as recent as 7, 8 years ago. Um, what we also have come to understand that the vast majority of chronic illnesses have some connection to a microbial ecosystem or dysfunction in a microbial ecosystem, right? So the vast majority of chronic illnesses is an ecological problem rather than a genetic problem or something that's much harder to try to reverse, which means that there's so much more hope than people think for all the conditions that people are suffering from, whether it's chronic conditions of the brain, the gut, the skin, the immune system, whatever it may be, weight, if you're trying to struggle and you're dealing with weight for years, all of those things have a very powerful microbial based resolution right around the corner, if not here already. Right. And so there's lots of hope for the conditions that you're struggling with. So get excited, empower yourself, listen to programs like this so that you can empower yourself with knowledge, because there are solutions that can work in conditions that did not seem that we could actually fix, just a few years ago. And the last thing about that is, you have so much more control of your outcomes than you think, right? For the longest time, health means your doctor, right? You go and you lean on your doctor for your health and your wellness and so on. And most of it was, of course, sick care for the longest time. Now, fortunately, we have a slight boom in the world of holistic health and preventative health and so on. So there's a little bit more wellness component to it. But at the end of the day, nobody has more power in terms of your outcomes than yourself. But it's about having the knowledge, having the understanding, and making the right choices, right? And some of these choices can be really, really simple.
I love that. That was almost perfect what you just said. That gives people a lot of hope because they do get caught up with their symptoms and their conditions and doctors telling them this and that. It is very discouraging sometimes. So to know that there's hope is amazing. So what kind of projects are you working on? Any updates? And then how can people connect with you?
Yeah, we're working on a lot of exciting stuff. So one of the areas of focus of the last year and a half has been on the gut-brain axis because of this epidemic of anxiety and mood disorders and all that we're seeing. It's just so prevalent. It's not managed and treated well. People are self-medicating all the time, right? Whether it's with alcohol or other addictive behaviors, people are doing things to try to help themselves, but they're taking the wrong approach. So we know that the gut microbiome is a big part of that. So we launched our first psychobiotic called ZenBiome last year. We've got, I think, 7 published studies on it now. Most most recently, we have a new biotherapeutic for Helicobacter pylori overgrowth. It's a probiotic bacteria that grabs onto H. pylori and takes it out of the system, doesn't touch anything else. It's not an antibiotic, not an antimicrobial, it's actually a lactobacilli probiotic that has a co-aggregation capability where it seeks out and grabs onto Helicobacter pylori and takes it out. We have a microbe that just came out that binds heavy metals in your system, in your gut, and takes it out of your system, right? And in the near future coming up, we've got microbes coming out that actually are going to completely change oral care. We've got a product called BioFresh Clean is the technology, and it's a technology that reduces plaque formation and alters the oral microbiome in a very positive way without even having to do brushing. So we have this mindset of where, like, can we make toothbrushing obsolete, right? Is there a better way to do it? And so we're working on that. That's coming out next year. So lots of research studies, lots of work coming out. We've got a gut brain, IBS, anxiety product coming out, all using unique microbes and certain types of keystone-like species. So lots of stuff coming out, lots of innovation. We're continuing to drive research. We'll probably publish 12 research articles next year. We've probably published 6 or 7 this year.
Wow.
So we're doing a lot of publication and adding to the collective knowledge, if you will, to empower and educate people. And I did about 75